Okay, so for polynomials, there's two things that we need to do when we classify. We talk about the number of terms, and then we talk about the degree. So there's two parts to the classification of a polynomial, okay? The degree is based on the powers, and the terms are based on the number of terms, okay? That's a number sign. And so I'm going to give you some examples. The other thing that we also it's not a part of the classification process, but it will be important later on, is we need to know the leading coefficient. Now, for some reason, you guys did pretty good on the leading coefficient. That's just essentially the term with highest degree. So in a polynomial expression is just a series of monomials. It's a sum of monomials, basically. And when we have a sum of monomials, we want to classify it because sometimes certain types of polynomials have certain graph shapes, which is helpful to know because remember, in the real world, what we do is we look at data and then we model the data based on equations. These equations are based on the degree of the equation and the number of terms. So it just makes sense to kind of have some names for them, okay? So let me write down some examples and then we'll go over the examples and talk about what they mean. So if I were to write down okay, that's a polynomial expression. 3x, 4x squared, y squared, plus 5 minus 3x cubed. Well, each one of these terms, this is a monomial, this is a monomial, this is a monomial, and this is a monomial. Okay? Now, a lot of times what we want to do is we want to put these monomials in what we call a standard form. We want to go from the highest degree to the lowest degree. But before I do that, I got to determine which what degree is each monomial. Now, degree is really just referring to how many variables are we going to have total for the term, just that term. So here I have x to the first power, so this is what we call a first degree monomial because that's x to the first. Well, now here I got to be careful because I have two x's, right? X times x is x squared. Y times y is y squared. So technically, this particular term has a fourth degree. In other words, there are four variables if you really were to expand that out. It'd be 4 times x times y times y. How many variables with the constant? 0. So we call that the what? The 0th degree. Okay? And then lastly, this would be x times x times x, so this would be a third degree. Now, one common mistake that I saw in the homework, when we asked the degree of the polynomial, what you guys did is you added all these numbers up. And you said, oh, it's 1 plus 4 plus 3, which is 8. This is an 8th degree polynomial. No, that's wrong. You got to go by the highest power. The reason we go by the highest power is because of the behavior of the graph. The highest power determines what the graph looks like. Okay, you guys don't know that yet. We haven't talked about that yet, but that's what it boils down to. The highest power is the most important thing of the polynomial. A fourth degree polynomial usually means that there's 4 solutions depending on the situation. Okay? It also determines what the shape looks like. So that's important. That's always going to be important to us. So now, the fourth degree polynomial and a fourth degree monomial, do you see the difference between the two? When I use the word polynomial, I'm talking about all these terms.
You're talking about many.
Yeah, many. Poly means many. Remember that, right? So now, if I were to write this in order, what I would say is 4x squared, because that's the highest degree. And then I would say negative 3x cubed, because that's the second highest degree. And then plus 3x plus 5. So that's the same polynomial, but now it's written in standard form. We also call this descending order, because it goes we also call that descending order. You could write it in ascending order, which means you go from lowest to highest. But 98% of the time we want to write it in descending order. Any questions so far? So now the highest degree, or the highest degree monomial, is also the highest degree of the polynomial. Okay, so this is a fourth degree. Now how many terms do we have? 4. Now we know that, and let me write this down. When it comes to terms, when it comes to the number of terms, mono is used for 1, bi is used for 2, tri is used for 3, and then poly is used for anything more than 3, and it means many. So we have 4 terms, so we're going to say that this is a fourth degree polynomial. Does that make sense to you guys?
Yeah.
Are there any questions about that? Yes? Yeah, I was just about to say that. The question is, well, what's our leading coefficient? Well, the leading coefficient is the scalar multiplier in front of it's the coefficient of the highest degree term. Okay, so since 4 is out front here, we would say that that is the leading coefficient is 4. Okay, the leading coefficient is 4. You had your hand up. Did I answer your question already, or did you figure it out? Yeah, okay. Any questions on that? Does that make sense to you guys? Are you perfectly clear? Well, what questions do you have if you have questions? You don't understand any of it? Well, let's start with one thing. What is it that's throwing you off? Okay. Well, we're doing 2 things. Actually, 3 things. We're determining the degree of the polynomial. Do you understand that? Okay, the degree of the polynomial is based on how many variables you're going to have in each term. The terms are separated by plus or minus signs. So everything in the pink circle is a monomial term. Does that make sense? All right, good. Now, this is first degree because it's x to the first power. Okay? This is fourth degree because I'll have x times x. How many x's is that? 2. Times y times y. How many y's is that? 2. So we're going to have a fourth degree term. So this term in this pink circle is to the fourth degree because that's how many variables we're going to have. Does that make sense? Okay. This one doesn't have any variables. No x's or y's, so we say it's the 0th degree. Does that make sense? This one has x to the third. If I were to expand that out, it would be x times x times x, which would be 3 x's. So that's a third degree expression, right? All right. Good so far? All right. So now, to determine the degree of the overall thing, we only look at the biggest one. So if I were to say to you, what is the degree of this whole polynomial? you look at the highest one, which is fourth, and you would say the whole thing is a fourth degree polynomial. Now, if I only had 3 terms, in other words, let's say I didn't have this term, you would say that it is a fourth degree trinomial. If I only had 2 terms, you would say it's a fourth degree binomial. Does that make sense? Okay. So that is the first part, determining the degree of the overall thing, the polynomial, and we have to determine the degree of each individual term. Take the highest one, and that's the degree of the polynomial. Another thing we could do is write it in descending order, which goes from the highest degree down to the lowest degree. So we did fourth, third, first, and 0. Fourth, third, that's supposed to be a 3. It looks like a 2. Where's my little marker? First degree, and then 0th degree. Then the number in the front is what we call the leading coefficient. Now remember, the coefficient is the number in front of the variable. It's what we multiply the variable by. So the leading coefficient is the number in front. And some of you guys, I noticed in your homework, you didn't, if it didn't ask you to write it in descending order, you didn't bother. You just looked at the highest degree. You got the right leading coefficient, right? So you could think of it as it's just the number in front of the highest degree. Any questions? Did I answer all your questions? Okay, good.